So example 1 at the bottom here asks us to expand 3a minus 2 to the 4, which is a joy, if you haven't noticed. So 3a minus 2 to the 4, what it is not is it is not 3a to the 4 minus 2 to the 4. 3a minus 2 to the 4 is actually 3a minus 2 times 3a minus 2 times 3a minus 2 times 3a minus 2. That is what it is. So you would have to FOIL, distribute, kind of ugly, right? And the chance of you making an oopsie pretty strong. We agree? Okay, let's go back to something that's a little easier. If I gave you x plus 3 times x plus 3, which is actually just x plus 3 squared, I end up with x squared plus 6x plus 9. We agree? So how many terms did I end up with? 3 when the exponent was a 2. We agree?
Yes.
So in this case, when the exponent is a 4, how many terms do you think I'm going to end up with? 5. That's it. Nothing rocket science-wise. So I'm going to end up with 5 terms, because it's always one more than this. And if you can't remember if it's one more or one less, because sometimes brains do that, go back to your easy binomial example. X plus 3 squared is 3 terms, so it's one more. Okay? It's always easier if you go back to the easy example. Now, I could FOIL, and then distribute 3 binomials together, or trinomials together, and do that. Okay? Then collect like terms and be done. Or what we can use is the binomial theorem. Now, the binomial theorem is actually on the next page. I'll get you to go there and we'll come back. The binomial theorem states that you can use this formula. T, k plus 1, nck, x to the n minus k, y to the k. Do you see that? So, what you need to know is that this, if I would write term 3, we did this in like 20-1, we did sequences and series. T3 meant term 3. We agree? T4 went term 4. We agree? Etc., etc. Okay? N is always your exponent on your binomial. So say my binomial is x plus 3 squared. Let's pretend it's just that. I'm just trying to get you to know what the heck the variables are. The binomial theorem only works if there's a plus sign in between them. Okay? So this would always be my x, this would always be my y, and this will always be my n. Okay? What if I give you this instead? X minus 3 to the 2. Now I told you I can only do a binomial if there's a plus sign, correct? So how I could have a plus sign between these is the first thing I would have to do is actually rewrite it as x plus negative 3 squared. Then this is my x, this goes in for y, and this goes in for n. Do you see the difference? If it's just a minus sign, you just have to go plus or negative. Okay? Now the k comes from whatever the heck term you're finding. So say I want to find term 4. Do you see that? Well, I want this to be term 4, let's pretend. In order for this to be term 4, what would k have to be? What plus 1 is 4? 3. Because I want this to be, it's like, yeah, get this. Okay, because I want this little number down here to be a 4, k would have to be 3. If I wanted to find term 7, what would k have to be?
6.
6. That's it. So do you see how I fill in letters? We go back to that? That makes sense? So let's go back to our previous example. So the binomial theorem is actually found on the very bottom of your formula sheet. It says, in the expansion x plus y to the n, written in descending powers of x, you can use the formula. But it has to be x plus y to the n. So, what's the first problem with this one? What's the first problem with this one? Yeah? It's a negative. So that's the first thing I'm going to do. I'm going to go 3a plus negative 2 to the 4. And then I'm going to label my stuff I know. I know this is x. I know this is y. I know this is n. Do we see that? And we have to be able to expand greater than degree 3 for calculus. So that's why I'm going over these ones, you have to be able to expand them. Now, we know enough information to be able to find this quite quickly. We know this has how many terms? It has 5, because it's always one more than the exponent, correct? So I know I'm going to find term 1 plus term 2 plus term 3 plus term 4 plus term 5. So remember, tonight's homework is to watch the Perms and Coms podcast, correct? And finish that quiz correctly. Try again. You might giggle at some of the stuff you did once you watched the podcast. Okay, so we want to find term 1. The formula that we use is the binomial formula. It's tk plus 1 equals nck x to the n minus k y to the k. Now this seems ridiculous, okay? But think of what's more ridiculous is foiling, distributing, collecting like terms. Or heaven forbid, 3a minus 2 to the 8. Good luck, Godspeed. You're probably messing up. I would be. Okay? So even though this seems a little bit time consuming, it's still way better than if we had to actually expand those up. Okay? So we want to find term 1. So I want to find term 1. What's my k going to equal? 0. My k is going to equal 0 here, correct? When I want to find term 2, what's my k going to equal? What plus 1 is 2? 1. So my k is going to equal 1 when I'm looking for term 2, correct? When I'm looking for term 3, t3, what would k have to be in order for this to be t3? 2. And in order for this to be term 4, what would k have to be? 3, because it would be 3 plus 1 would give me term 4. We agree? And then term 5, this would have to be 4 plus 1, so k would have to equal 4. K is the only thing that changes on every single one of them. The rest stays the same. The rest is, this is what I have to fill in right here, correct? That's what I have to fill in every single one. Well, n will be 4 for all of them. X will be 3a for all of them. Y will be negative 2 for all of them. The only thing that's changing in each of these terms is k. And k is always 1 less than the term number. So let's try and find term 1. Term 1 is n, which is 4. C, k is 0. And then x is 3a to the n, which is 4, minus k, which is 0, and then y, which is negative 2, to the k, which is 0. That's term 1. So I just filled it into the formula. What's 4c0? Well, if you have 4 things and you choose none of them, how many ways can you do that? 1. I just go there and I'm like, okay, I'm not. And I'm 1. There we go. So this is going to be 1. 4 minus 0 is 4. Now this is the error that happens in these, and when they're on the diploma, they would often error them this way. They'll give you the answer if you forget to put the 4 to the 3. So the 4 has to go to the 3, and the 4 has to go to the a. Do you see how that could be an oopsie, where you'd go 3a to the 4 when it's actually 81a to the 4? Because 3 to the 4 is 81, so this is in brackets. These are all multiplied. This is multiplied by this, is multiplied by that. 81a to the 4. And then what's negative 2 to the 0? What's anything to the power of 0? 1. So it's actually times 1. So what is my first term? 81a to the 4. So once I expanded those two binomials out, then distributed the two trinomials, when I would get them in descending order, my first one would be 81a to the 4. So it's not super less time consuming doing it this way when you're expanding the whole thing out, correct? It's not as time consuming, like it's not like it just saves you tons of time, but less errors will happen. And secondly, this is a lot faster if I just ask you for term 4. If I ask you for term 4, you just find term 4 and you're done, right? If I ask you for term 4 the other way, you have to expand it out, collect like terms, put in reducing powers of x, and then give me term 4. It should take way longer. Okay, now term 2. How do I get term 2? Well, I'm going to add n. I'll do term 2 in green. N is 4. C, k for term 2 is actually 1. 4c1 times x, which is 3a, to the n, 4 minus k, which is 1. And then y, which is negative 2, to the k, which is 1. What's 4c1? I don't know why I wrote it down here. It should be here. What's 4c1? How can I have 4 objects and choose 1? How many ways can I do that? 4. Choose 1. Well, no, I'm going to choose that one. Then I'm going to choose that one, and then I'm going to choose that one. So there's 4. So 4 choose 1 is 4. And then this is going to be 3 to the 3, because 4 minus 1 is 3. 3 to the 3 is 27. A cubed. And what's negative 2 to the 1? Negative 2. Now multiply all these coefficients together. What's 4 times 27 times negative 2? Negative something. I just want to adjust my glasses that don't exist again.
Negative 216.
Negative 216? Yeah. A cubed. Now I have term 2. Now if I want term 3, it's exactly the same, but the zeros or the 1s become 2s this time. So now I'm going to get plus 4c2, because k is 2, and then 3a to the 4 minus 2, negative 2 to the 2. 4c2 is 6, I believe. Is 4c2 6? I think it is.
Sure. Sure. We'll say it is.
Okay, you guys just, yeah. And then 4 minus 2 is actually 2, so it's 3 squared, which is 9a squared. And then negative 2 to the 2 is actually positive 4. What's 6 times 9 times 4? Positive. How much? 216 again? A squared. Now I still have term 4 and term 5 left, right? Go back. I'm doing Christmas colors unintentionally until I just noticed right now. Okay, so we're going to go 4c3. 3a to the 4 minus 3, negative 2 to the 3. 4c3 is 6. Then this is 4 minus 3, which is 1. 3 to the 1 is 3, a to the 1 is a. So 3a, and then negative 8. Negative 2 cubed is negative 8. So what's 6 times 3 times negative 8?
Negative 144.
A. And then we have one last one. And so I have plus 4c4, it's case 4 this time, 3a to the 4 minus 4, and then negative 2 to the 4. 4c4, how can I have 4 things and choose 4 things? One way. I just chose them all. There they are. It's aggressive. Because there's cups on there. 1. Then 4 minus 4 is 0. What's 3a to the 0? What's anything to the 0? 1. And then negative 2 to the 4 is 16. So it's going to be plus 16. So if I have to expand the whole thing out, which I just did here, it's 81a to the 4 minus 216a cubed plus 216a squared minus 144a plus 16. So not extremely reduced in time, correct? But it is reduced in time if I just ask for one term instead of asking for all the terms. It's also way, it's just much better chance of you not making a mistake. If it was like 3a minus 2 to the 10, I'm sorry, you're probably making an oopsie. Actually, we'll run out of paper. Like, get yourself some bristle board or something. Yep.
Never mind. I thought the a was, or the 81 was a to the squared, and then I was going to ask if you would combine the two a squared, but it's okay.
If it was, second guess yourself, because this should be the simplest, like when you're done, it should be in simplest form. So if you can put terms together, something's wrong. Okay. Let's go, oh my gosh. Here, I want you to do this one. So we're going to find the third term of that. How many terms would this one actually have? This one would actually have 8 terms. That would take a while. I wouldn't have given you enough room, correct? But am I making you find all 8 terms?
No.
No, I'm making you find the third term. So I want T3. What's the problem with my binomial currently?
It's a negative.
It's a negative, so I can go plus and then make it be a negative 5. We agree? Now, in my binomial, this is x, this is y, this is n. I just need to figure out what the heck k is. If I'm looking for term 3, what is k? Equal to? 2, because the formula is tk plus 1 equals nck x to the n minus k, y to the k. So, if I need tk plus 1 and I need to be term 3, then k would have to be a 2, because 2 plus 1 is 3. We agree? Then we can just fill it into the formula. So term 3, so we're going to go t2 plus 1, right? Because I'm filling it right into this formula. Do you see that? T2 plus 1, which is actually 3, which we'll do in the next step, equals n, which is 7, ck, which is 2, to the x, which is 2x, n minus k, so 7 minus 2, and then y, which is negative 5, to the k, which is 2. So I'm literally just filling them into your formula sheet, right? What is 7c2? I don't know what that is. So this is T3 equals, what's 7c2?
21.
Pardon?
21.
21. And then I'm going to get 7 minus 2, which is actually 5. So 2 to the 5 is 32. X to the 5. And then negative 5 squared is 25. Now what's 21 times 32 times 25? I do not have that memorized in my head. 7.
160 or 16,800.
X5?
Yeah.
There we go. So finding just one term is way faster doing it this way. Yes, I know finding all the terms would have taken us, that was one term. I would have had to find 7 more, correct, to do the whole thing. But I probably wouldn't have made an error that way. But when they ask you to find one term, it's a lot faster. That's the big teaching lesson for binomial theorem. Back here. So if we go back to this very first page, there's something called Pascal's triangle. Pascal's triangle is literally this. You start with a 1, and then your outside lines will always be a 1. So then I go 1, 1. I'm making a triangle as I go down. Then outside this one, I get a 1, because my edge on the right and on the left are going to always be 1s. And then I add these two. 2, and then I get a 1 again. Because my left and right outside edges have to be 1s. Then I start with a 1 again, and now I add everything in the middle till I get to a 1 again. So now this is going to be 3, 3, and then I end with a 1 again. Do you see that? And then I go 1, and then I get 4, and then I get 6, and then I get 4, and then I get 1. Now you can see why I predicted that that middle one was probably a 6. Because I was actually using Pascal's triangle. It would keep going. This would be 1, 5, 10, 10, 5, 1. But the one I care about to show you with this one down here is this row here. Because how many terms does this row have? 1, 2, 3, 4, 5. Do you see that? 1, 4, 6, 4, 1. How many terms did this one have down here? It had 5 as well, correct? So if you look here, just for the C part, 4C0 is, oh, why did I pick green? I picked purple. 4C0 is 1. 4C1 is 4. 4C2 is 6. 4C3 should have been 4. How'd you guys not comment me? This is a 4. This whole thing was an error. And then this is a 1. No one even corrected that crap.
I'm listening.
What? You're listening, but no one multiplies. 4C3 is 4. 4 times 3 times negative 8 is what? What's 4 times 3 times negative 8? Type it in. Someone. Anyone. Euler.
Negative 96.
This should be negative 96A. That should be negative 96A. And I caught my error because I knew I know the Pascal's triangle. And in this one where it has 5, it should have went coefficient of 1, 4, 6, 4, 1. Do you see that? And I had 1, 4, 6, 6, 1, and no one stopped me. No one. The belief in me is real strong, but you guys need to reduce it a little bit. Don't even check it. So it just lines the C part lines up with the numbers of the Pascal triangle. So review tonight is that